Pre-Calculus Lesson 6-6, Modeling Real-World Data with Sinusoidal Functions. So we're going to just have some real data that was given to us and collected. Our first example says to write a function that models the amount of daylight for Brownsville. This is on the very first thing that comes up. It's the word problem. So it says this table right here contains the times that the sun sets and the sun rises on the 15th of every month in Brownsville, Texas. So T is 1, and that's January 15th. These are all on the 15th of the month. So we have 1 through 12, okay? We need to write a function that models the hours of daylight for Brownsville and then use our model to estimate the number of hours of daylight on September 30th. So I'm going to use this, see if I can fit it all on here. We have the month, T, which in this case is just the number of the month, and the hours of daylight. So we have January, February, March, April, May, June, July, August, September, October, November, and December. Okay, the T. These all January, February, it's just the number of the month. It's the first month, second month, third month, and so on. Now, the hours of daylight. To figure out what the hours of daylight would be, right here we have the sunrise and the sunset for January. To figure out how many hours of daylight, you could probably do it in your head, but you're going to want to change them to a 24-hour clock. You're going to want to change your PM time to a 24-hour clock. So in the AM, for January, the time goes from 7:19, and the PM, if you want to change it to a 24-hour clock, you do 6 plus 12, because the sunset, this is what this should say. The sunset, it sets at 6 p.m. So add 12 more hours to 6 and you get 18. 18 o'clock, if you want to talk. It's kind of like military time. So what you're going to do, we know from 719 to 1800 hours, that's the amount of daylight that you have. So let's add these together. Write them first as a decimal. Change each of them to a decimal. This is going to be 19 minutes out of 60 minutes. So this changes to 7 plus 19 over 60. Here, it's just going to stay as 18. If you want to write it as a decimal, 18.00, because there's no time after the hour time. Here, there's 19 minutes out of 60 minutes in an hour. So if you wrote it as a decimal, you'd get 7.32. If you wrote this as a decimal, again, it's the same, 18. So on January 15th, to figure out the number of hours of sunlight, you just do the larger number minus the smallest number, or the sunset minus the sunrise. You're gonna get 10.68 hours. So that's what you'd put in here, 10.68. You can do that on all of the rest of these. So I want you to pause the video, figure out how many hours of sunlight each month has on the 15th of the month. Okay, so I'm going to fill this in. See if you got the right answers. I'm running out of space. Okay, this is how many hours of daylight that Brownsville, Texas had on the halfway through the month, on the 15th of the month. So we need to write a function, and we're gonna use a sine function to figure out the amount of daylight. So I'm gonna go up here, we are gonna refer back to this. We're gonna use our sine function, which is y equals a times the sine of kt plus c plus h. T is our time in months. We have that right here, 1 through 12. And we're gonna find A, H, and K. So we have to solve that. A is just the difference between the most daylight and the least daylight. So down here, if we look, who has the most daylight? 13. Looks like June has the most daylight. The least amount of daylight, we have 10.68. 10.53 in December. So you're gonna find the difference between these two and divide it by 2. So A equals 13.75 minus 10.53 divided by 2. If you find that answer, you get 1.61, just round it to 2 decimals. To find H right here, you're gonna add the greatest value and the least value. So now you add these two and divide it by 2. So that's gonna be H. If you add them, the most amount of sunlight and the least amount of sunlight, divide it by 2, you're gonna find H, which is 12.14. We also need to find K, or our period. So you're gonna use the formula 2 pi over K. You're gonna use your period formula. I'm gonna run out of space. The period is 12 because we have 12 months, January to December. Okay, solve for K, so multiply both sides by 12. By K, you get 2 pi equals 12K. Divide both sides by 12. Pi over 6 is our period. Is K. The period is 12. Plug everything in here and we'll have our written function. So y equals A, which is 1.61, times the sine of K, which is pi over 6, T plus C plus H, which is 12.14. Now we can solve for C and we'll be able to have our whole formula written. You can do all of this. I want you guys to figure this out yourself. The thing that we're going to do is we're gonna substitute one of our pairs down here to be able to solve for C. Okay, so our pair, we're gonna use T as our time or the month, and then we'll substitute Y for it. So let's use, you can use any one you want. I want you to pause it. You choose which one you like. I'm gonna use the 1 and 10.68, the very first one. You can use any of them. Okay, so 10.68 equals 1.61 times the sine of pi over 6 times 1 plus C plus 12.14. I just used the first month, January. If you solve all of that out, you can find C. You can do this on your calculator. I'm sure you've been working all of these out. So negative 1.6593. I'm not going to go any further. That's what C is. So your function is, we'll plug back in here for C. We'll plug in, let's plug in negative 1.66. So negative 1.66, I'm rounding this second decimal point up to 6, plus 12.14. This is our function that models all the data that we're given for Brownsville, Texas. Then it says, use your model to estimate the number of hours of daylight on September 30th. So here's September. It's the 9th month. And we want to find out how much daylight they'll have on September 30th compared to September 15th. So between September and October, it's just 1. The value is 1. So to find what's halfway, since the 30th is halfway between the 15th of September and the 15th of October, we're going to write our September, we're going to make it 9.5. That's what our time is going to be, or T. because it's halfway between September and October. It's on the 30th. So now you can use your calculator. We're going to use our function right here, and we're going to plug in for t, we're going to plug in 9.5. Oops, I forgot the t up here. Y equals 1.61 times the sine of pi over 6 times 9.5 minus 1.66 plus 12.14. So you can do this on your graphing calculator, or you can do it by hand. If you put that all in, you should get 11.86, and it keeps going a little bit longer. But basically, between September and October, on September 30th, they're going to have about 11.86 hours of sunlight. If you want to just round it up to one decimal place, you can, but that tells you that we know it's going to go down a little bit, just because 12.3 hours and 11.7 hours in October, it's going to be somewhere between there, which it is. So your homework, I will let you know what your homework is for lesson 6-6.